Hey, Vincent here. Welcome to another episode of Vlog Sen. So of course, we're gonna explore some new stuff. We're gonna talk about some of the mundane things that can be explained by science. Hey, do you ever wonder where your stomach balloons when you're here and flattens when you exhale?
No, but for sure it looks funny.
Dude, why do you think your ball gets a lot bigger when you pump air?
Because I put a good amount of air. Duh.
Nice bubbles. They remind me of my childhood. But do you know why they vary in sizes? Some are bigger and some are smaller. Think about it. Why does this exactly happen? Well, all of these are explained by a gas law called Avogadro's law. Not Avogadro's law, but Avogadro's law. And that law explains that the volume of any container is directly proportional to the number of moles, or the amount of gas inside it. In other words, the more gas there is inside the container, the bigger the volume will be. If there's a less gas in a container, the volume will be smaller. But who made all this explanation so concrete? Meet Amadeo Avogadro. Yes, he has a pretty long name, but let's just call him that. Amadeo. He does seem like he's from Cavite, cause Amadeo. Apart from being the proponent of Avogadro's law, he's a professor, a physicist, and the guy who discovered the Avogadro's number, which is 6.02 times 10 raised to the power of 23. Amazing, right? So why don't we tune into the sneakerhead, Smarty Pants friend of mine? Today's show would never be complete without this cool guy, Carl Galvez. Take him scream.
Hey everyone, I'm Carl Galvez, and in today's segment, we will be talking about Avogadro and his law. Well, did you know that Amadeo Avogadro was born into a noble family? And he used that advantage to study math and physics extensively. And with that advantage, we now propose what we know, the Avogadro's law. The formula is the initial volume times the final number of moles is equals to the final volume times the initial number of moles. Now, with that said, the pressure and temperature is always constant. Now, let's get to solving and get our calculators.
3 balloons are filled with different amounts of an ideal gas. One balloon is filled with 3 moles of the ideal gas, filling the balloon to 30 liters. The situations are: A. One balloon contains 2 moles of gas. What is the mole of the balloon? B. One balloon encloses a volume of 45 liters. How many moles of gas are there in a balloon?
Avogadro's law says the volume is directly proportional to the number of molecules of gas at the same temperature. This means the ratio of N to V is equal to a constant value. Since this constant never changes, the ratio will always be true for different amounts of gas and volumes. For the formula, Ni divided by Vi is equal to Nf divided by Vf, where Ni is equal to initial number of molecules, Vi is equal to initial volume, Nf is equal to final number of molecules, and Vf is the final volume.
Part A. One balloon has 3 moles of gas in 30 liters. The other has 2 moles in an unknown volume. Plug these values into the above ratio. 3 moles divided by 30 liters is equals to 2 moles divided by the final volume. To solve for the final volume, 3 moles multiplied to final volume is equals to 30 liters times 2 moles. 3 moles times final volume is equals to 60 liters times mole. As a result, the final volume is 20 liters. You would expect less gas to take up a smaller volume. In this case, 2 moles of gas only took up 20 liters.
This time, the other balloon has a known volume of 45 liters and a known number of moles start with the same ratio as before. Ni over Vi is equals to Nf over Vf. Use the same known values as in Part A, but use 45 liters for Vf. 3 mole over 30 liters is equals to Nf over 45 liters. Solve for Nf. 3 mole times 45 liters is equals to 30 liters Nf. 135 mole times liters is equals to 30 liters NF. NF is equals to 4.5 moles.
How do we actually relate this to real life situations? Well, all of the things that Vincent saw just boils down to this law. Cool, right? But let's take a rewind and let me show you how all of those things happen with that law. First is the breathing process. When you inhale, you intake so much more air, so there is more gas in your lungs, thus seeing your stomach expand. The reverse happens when you exhale. It gets smaller because there is less air, hence the less moles you have. The same thing happens when you inflate balls and balloons. A flat ball means that there is much less air compared to an inflated ball. What is the reason why there are more moles in an inflated ball than a flat ball? That phenomenon can also be seen in blowing bubbles. Don't you remember how amazed we were when we get to blow bigger bubbles? Well, we observe bigger bubbles when we blow more air than how we blow when we get smaller bubbles. And this wraps up my discussion for today. Thank you for watching. Back to you, Vincent.
Thank you so much, Carl, for that insightful explanations. And thank you too for tuning in with us in today's show. I hope you learned something from us. If you like this video, click subscribe and turn on the notification bell to keep you posted. This has been Vincent Reyes, and let's keep this takeaway from Carl Sagan. Somewhere something incredible is waiting to be known. And you are watching Blood Scent. If you like this video, smash the subscribe button and ring the notification bell to keep you posted.